run analysis, and then just I think there are too many wind loads. Let me delete. Click here, analyze and run analysis. So once you go and click here, run now, it will do the analysis. Why did that? Okay. It's done. Now you want to see the shear force diagram and the bending moment diagram for this beam. Go to display. So, if you right click, you can see how much was the total load?
6 into the distance. 6 into the distance, which was 10.
Can I have your calculator? Okay, I have it mine with me.
It will be 60. 6 into 10. 60.
It is perfectly 60. 60 over 2, 30 on one side and 30 on the other side. I was checking the moment for your information. It was 75. If you use WL square over 8. Okay, calculate the moment at the center now. Now you know the beam. The beam is simply spotted. The beam is simply spotted. Find out the moment at the center. How much will be that?
300 to 300. بالك مومنت
No, at the center.
maximum moment 60 into 5. 75.
75. So what will be the equation for moment? M will be equal to 60 for 30 into 5 minus 6 into 5 into 5 over 2. Whatever. I mean, this is direct movement. You will get direct movement with this equation. The movement at the center of the beam. The beam length is 10 meter. Yeah. So at the center, how much will be the moment? 30 into 5 minus 6 into 5 into half. Check, how much is that? Okay, 75. Okay, if you know some better way than this, do by that way. Okay, if you don't agree with me, do it by that way. But it is 75. Let's see that. So, if you, this is scroll bar, you can click and you can drag this. It tells you the shear force at every point 0,000 meter. So at the center, you can see how much is the moment. Can you see?
75. Almost 75.
Almost 75.
Because it's not center.
Yes, exactly.
And if you see at the bottom, what is that?
Deflection.
So this beam will be having how much deflection?
0.06 sorry.
6 million.
It's around 60 millimeter. 0.059 or 0.06 meter. So 6 centimeter or 60 millimeter. 6 centimeter is how much?
6 centimeter.
something like this.
Yeah.
Ah, maybe like this. So, too much? The code says the deflection should be less than L over 240. 240. So is it safe?
I know, yes.
Check it. 10 meter over 240.
0.04.
0.0.
Oh, yeah, 4 centimeters.
So exceed.
So it's
For
failing.
something.
This beam is failing in deflection.
According to the code.
According to the code, this beam is failing in deflection. This beam has a deflection 0.06. You want to check the design that this beam is safe or not? According to the code.
Yes.
Okay, it's very simple. Go to design and just click this button. Start design, and I think it's not safe. I'll show you. Right click. I have not defined the code. Before that, I should tell the code. Yes, it is AISCLRFT. And I think no one of you can take steel design. No one will be taking steel design.
Next semester, no. It's not available.
Also in this semester.
Of course.
So these are the limits. Anyhow, so that's why you don't know about all these. What is phi and what is phi in bending, what is phi in compression. Okay, design. Start design and check of structure. Beam 1. Design steel and display design information. POM. Okay, it's badly failing.
Yeah.
This ratio is 4.62. What is this ratio? This ratio is required force, required bending moment. How much is that? 75.
Yeah.
Divided by the capacity of beam.
Okay.
Do you understand or not?
Yes.
So it means the capacity of beam is 4.682 less than the capacity of beam is somewhere, let me tell you, 75 divided by 4.6. The beam capacity is 16 kilonewton meter. What is the capacity of beam? 16 kilonewton meter. And how much was the moment? 75. So the required moment is how much? 75. Just divide 75.
By 6. For time.
We call it unity check. That is equal to the required load divided by capacity of the beam. So in this case, how much is that? It is 75 was the required divided by 16.
Yeah.
So
4.69.
is your beam safe?
Absolutely.
So what you should do? You want to pass it?
No.
No.
You want to make it safe?
Yeah.
Of course.
Okay. Now I make it safe. How we can make it safe?
Maybe decrease the load on it.
Reduce the load? No. You cannot reduce the load. Is a fixed entity on a structure.
Increase the weight.
Maybe.
So then please see here, it is unlocked. You cannot make any changes because you have done the analysis. So if you want to make any change, for example, how you can revise a section, you can go to define frame section, and here you have beam, but you cannot make any change. Can you see it's all locked? So if you want to make a change, unlock.
Maybe we add a reaction.
You have a beam here, no need.
Increase the.
So I should 10 meters is a huge span. You know, based upon my experience,
6 meter, the average.
it should be, for example, as a steel designer, if I'm designing this beam and the load is this, what I will do, I will put, I recently did one, I put 0.6 meter minimum, 0.6 meter deep beam, 0.6 is something this. And then flange I will keep, that will be my first trial. 0.2 meter, okay, illegal. 0.2, flange thickness, I will put 0.01, 10 millimeter. And this is the web thickness. Web thickness I will keep for this beam 0.06 or 8. And 0.2. Yes, the bottom flange thickness 0.01. Oh, the web thickness. See the web. Can you see?
Yeah, the way.
It's very thick. It means it is. I put it wrong. It should be 0.06 millimeter. This 6 millimeter is this much. As a steel designer, that would be my first trial as a steel design engineer. See, it looks very thin.
Yeah, they should maybe like.
Let's see.
12.
I mean, it could be wrong, but that would be my first trial. I'm not saying the 100% correct. I'm saying that would be my first trial as a design engineer. Or I will put 0.25 if the loads are heavier. Okay. Then let's see what happens. Run analysis, run. My computer is a little bit slower. Although it is i5, steel frame design and start design and check of structure, still failing. Let's see how much failing.
How we know?
Okay.
It's a red.
It's failing. If this value is greater than 1, it's failing. But how much failing? This we check. 1.19.
Yeah, we decreased it from 4.6.
You understand? I mean, it is my trial. I was very close to capacity, the required movement over capacity. If this value is 1, it means both are equal.
Yeah.
See here, if this value is equal to 1, it means required load is equal to capacity. So if I'm getting 1.19 something, it means my trial is very close, but still not safe.
Yeah, we must make it.
Very
Three.
good.
Capacity
Yeah.
now is 63. No, 0.3.
63 capacity.
Okay, so what I do, well, I think if I will do this, how I will make it safe? Modify and show property. Now, what should I do?
Increase
The
5 point.
the thickness.
I will just increase the thickness of flange or the width of flange. I make it 0.25, but it will be a little bit uneconomical from my point of view. So now it is 0.25. Just see, it's like a paper. I mean, it is very weak. I mean, optimized section. How much is 6 millimeter? So this web, I put this web 6 millimeter. If some other designer will see my design, he will say, "Oh, what are you doing?" But I will show you my design. When I design, I designed like 0.9999. 0.9999. I have a very famous quote about design that if a sparrow sits on your steel beam, it should fall down extra than the load.
What is?
Very
If a bird or a crow, extra crow other than your load, if it sits on your beam, it should fall. Do you understand or not?
Yeah.
The economy. Such an economy. It should be safe. Safe and economic. But many engineers don't like this idea.
Yeah, they move.
They,
Towards
I
the
mean, the
safest.
people, they keep it below 0.8. They keep their design below 0.8. But when I design, I don't like less, less than 0.95. I don't like that. I don't know, but for that, but when I started, I keep it 0.8. Do you understand?
Yeah.
What does it mean?
It means that the required load is 1/5 below the.
I mean, why this change happened in me? I mean, when I was a designer, I started, I keep it 0.8. But now, if I design something, I keep like 0.999. Why?
There's no big difference.
More economic. Now it's more economic.
But why I was not economical when I started?
Safer. You were a beginner like us, so.
So, it means that you should have sufficient experience and confidence. Don't be overconfident. Okay. If the load is, if you keep it at 0.8, you have enough margin in your beam. If there is any uncertainty, okay, it will be covered. But if you keep it 0.999,
Everything must be in detail.
perfect. I mean, you should have not done any mistake. Do you understand? If you do that, you have to face trouble.
0.999.
Yeah, I recently done one design. But how to show you the picture? This is the problem here. I don't have Facebook on my computer. Okay, so let's check. It will pass. I think at this it should pass until and unless shear will go on. What did I say? Maybe you do not understand. I know, because if you do understand, then you are a genius. Sign me up. Okay.
Yeah, it's in green.
So you can see in which range it will be.
Between 0.5 to 0.7.
7. Is it economical?
No, absolutely not.
If it is 0.5, it means you are giving extra. Design. Design display. .665. So it is safe. Let's see the deflection now.
Victor, make it 0.9.
Make it 0.9.
999.
This beam is very easy to make it 0.9, but when you have to make a frame which have like 30 beams or 30 components, that is much more big challenge. You know, you want to see my design? Well, I will be a little bit away from the topic, but well, because I did on the stat, let me show you. Just give me 1 minute.
Teacher, like the factor of safety in your design is like 1.2.
In my design, factor of safety is
For steel.
is higher than that. Is higher than for steel. It depends upon the core. Which core? For example, if you are talking about LRFD, it is dead load 1.2 and the live load 1.6. Okay. But if you are using the other way, so in the other way we reduce the material strength. Let me show you some of my stat design unity checks. This is from one of the project. So many beams. It is a frame, a very big frame, maybe 30 meter, 30 meter and 30 meter. Sometimes you cannot reduce them this value. I mean, I cannot, because you have many other limitations. Like you have a uniform cross section going on. You cannot. So sometimes, for example, it is the same column. The column is same, but this column has two parts. So the bottom part, 0.592. It's the top part is governing the strength. For example, the same column coming down. Do you understand? So at the top it is 0.925, but at the bottom it is 0.592. So this governs. So this is one of my design, real design. This is not something hypothetical.
Teacher, like different properties between the two.
See here. This is
That's what I mean, like thicker.
This is the design shape. This is how I design. For example, I do not provide a uniform cross section. From here, at this moment, at this point, the unity check was 0.8. 0.696. That segment or that part is this part. Can you see this part?
Yes.
Sometimes, for example, I have reduced the depth so much that deflection, there are two things, one is strength and one is deflection. So you have to check both. Sometimes unity check is 0.6, but deflection is high. So in order to control in deflection, you have to keep up. So if you see somewhere, and this is how I provide beams, I do not provide a straight beam. I taper the beams. You understand?
Why?
Why? Because there is very less bending moment at the sides.
Yeah, the reaction.
If you right click here, analyze and forces display frame momentary 3 that was live. Okay. Okay, how much is deflection now?
0.007.
Just
7
millimeter. It was before 60 millimeters. 4. So, but what I wanted to show you,
But teacher, one question.
I forget.
Why
I
it is
wanted-
not uniform beam?
So this.
Yes, sorry. See here, the bending moment is 0. Here, and the bending moment is 0. The maximum moment is here. So why not we should follow the bending moment profile when we design? So that's why if you see my beam, it is like this. Do you understand or not?
Yes.
Many people don't like this idea. They say you save too much and you make structure
Too dangerous.
too dangerous. But to play on the threshold, I tell you, either you should be the confident or you should be the ignorant.
Yeah.
There is no midway. But Alhamdulillah, I have designed many structures and still they're safe and standing.
If you're still standing here, then they are safe. If they're not, you will not be here.
Yeah, I wish that they will remain safe. So this is we have done with the shear force diagram, with the bending moment, and with the reflection. It is the continued lecture. Just one point. Okay, just last point, and after that I will open the fish market for you. Okay, so now this beam is the simplest portion. You want to make this beam cantilever? Let's make it cantilever. You know cantilever beam? Having fixed support on one side. Okay. So how you can do that? First unlock. I just click this joint. I click here, and then I go to assign joint restraints, and if I click on this, it will become fixed. You want to keep this support here, or you want to remove this?
Remove. Cantilever.
Okay. You want to see the load? That whether you have the load, just hold down. The load is there. You go to display, show load assigns, dead, live. Okay, let's see live load. So it is live load is there. Okay, now what I do, I run the by right click. So here you can see this is the shear force. How much is the total shear is now on one side? Can you see? 60 on this side.
Yeah, it's taking all the load.